All right, let's do this example here. We want to use a truth table to show that this logical formula is indeed a contradiction. So it's in kind of two parts. We need to figure out what the negation of P implies R is, and the negation of P or Q, and then take the and of those statements. So let's get going. So notice that this is our first example where we have indeed three different constituent statements, P, Q, and R. So we're going to need a larger truth table with P, Q, and R in it. So the easiest way to think about it is for each scenario, when you just had P and Q, a situation would be, say, P is true, Q is true. Write that twice because R could be either true or false. So pause the video now and see if you can come up with the other rows in our truth table for the truth values for P, Q, and R. Make sure you got them all. Okay, now that you're back, let's fill it out. So we had P is true, Q is true. Now we have P is true, Q is false. We can write that twice again. And we have R could be true, R could be false. Then we had P false, Q true. And again, R could be true or false. And finally, we have both P and Q are false, and R could be true or false. And I just want to point out, you don't have to think about it like this all the time. Notice that here, the P has 4 truths in a row, then 4 falses. The Q alternates between 2 truths, 2 falses, 2 truths, 2 falses, and R alternates true, false, true, false, true, false, true, false. So if you notice that pattern, you could just write that down right away and you don't have to think too hard. Okay, so now that we have that, we need to complete our truth table. So let's determine what different columns we need. We need P implies R. We need the negation of that. The negation of P implies R. We need, let me just get a little more room there. We need P or Q. We need the negation of P or Q. And then we just need the and of these two columns. I'll call this column X, I guess, and this column Y. We need X and Y. So that's what we need. So maybe pause the video here and try to fill in the truth table. We know how to do implications, we know how to do negations, we know how to do ors, we know how to do ands. So see if you can figure this out. Okay, now that we're back, let's do these. So here we have an implication. Remember that an implication, an if-then sentence, is only false exactly when the if part is true and the then part is false. So it's when P is true and, in this case, R is false. So it's in row 2 here, and it's also in row 4, and they're the only times. So we have true, false, and then the rest are true. So hopefully you got that. And then we have the negation of that, so we just negate all of the truth values. That's easy. False, true, and then 4 falses. Great. Okay. Now we have P or Q. Remember, that's false exactly when both P is false and Q is false. So that's down here and in no other place. So let's put that in. True, 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 false, false. And then in negation of that, flip the truth values. False, 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 true, true. And now we have the and, the conjunction of these two columns. I just labeled them X and Y just for space issues. So remember that an and statement is true exactly when both parts of it are true. So we look here. We have false, false. So this is false. We have one of them being false. Two of them false. Still makes it false, of course. Here we have Y being false in the second row. So this is false. X is false and Y is false. Just need one to be false. Here we have Y is false. Here we have both are false. Here we have both are false. Here we have X is false. Here we have X is false. So that is the truth table complete. And you can see here, no matter the truth values of our statements P, Q, and R, it doesn't matter. This logical formula here is just always false. This is never true. So this is indeed a contradiction. So in summary, if you're doing a truth table or anything like that, remember that tautologies are always true no matter the truth values of the constituent parts, and contradictions are always false no matter the truth values of the constituent parts. And that's how tautologies and contradictions work. Maybe one quick note. If a logical statement, or logical formula, we'll say, is true in one instance and false in another, it cannot be a tautology or contradiction. And I'll explain what I mean by instance right now. I mean that an instance, I mean a particular set of truth values for your constituent parts of your logical formula. That's what I mean by an instance in this case. So that is tautologies and contradictions.